According to infopolice.com, in 2000 there was about 6 million people on Earth, and according to geohive.com, in 2010 there was about 7 million. If you subtract the year 2000's population from the 2010 population, you get the difference, or how much it grew in the span of 10 years. This comes out to about 833 million. To get the growth rate, I divided that number by the population in 2010, and this comes out to about 0.121, or 12.1%. This means that the world population grew about 12.1% in the 10 years between 2000 and 2010. I will be using this rate to find the projected world population for many years in the future. For exponential functions, the formula is y equals a times b to the power of x. In this equation, y is the total population, or total projected population. Then I put the year 2000's population because this is where I want the data for my table and graph to start. Next, the growth factor would consist of 1 plus the growth rate, which is 0.121. Lastly, the growth factor would be to the power of x. In this equation, x is the number of decades since 2000 because this is our starting point. After creating this equation, I entered it into my calculator and created the table. To make it easier, I created a new table where I will round the numbers to the nearest million. In this table, I'm going to record from 0 to 5. Then I made a graph that has the x and y variables on the axes, and the y-axis is counted by billions. From the table, I plot the points. The y-intercept would be the population of the world in 2000. Then, following the points I plotted, I drew the line of best fit. You can see that this situation isn't linear because the line is curving and linear functions would not do this. Since I'm doing something that is mostly in the future, I thought of a what-if situation that would greatly impact my exponential function. For this part of the project, I'm going to think of what would happen if the supervolcano located inside Yellowstone National Park were to erupt in 2020. There are many theories on what would happen if it were to erupt, but here's just one of them summarized. The eruption would create a cloud of ash that would cool down temperatures because it will filter much of the sunlight, which would cause agricultural production to decline and also the crash of the economy. This would cause people to starve from lack of food and money to get it from overseas. With all this starvation, some people who see America or any other country affected by this collapse as a threat might start a full-scale war, which would be chaos. For the decay rate, there isn't much research on how the population will be affected in the time following the eruption, due to the many theories and variables that could influence it. So, for the purpose of this project, I thought of a 10% population decrease each decade because I think that the death would outweigh the births. This will be a function showing the exponential decay of the world population. For this equation, the x and y variables remain in their same positions and y is the same, but since my what if will happen in 2020, x will be decades since 2020. According to intellihub.com, about 90,000 people would die instantly from the eruption, so I took the projected population from the year 2020 and subtracted 90,000, so this will be the y-intercept. Next, the decay factor would be 1 plus the decay rate, which would be negative 0.1. This would be equal to 0.9. To create a table, I did the same thing I did with my previous data and put it in my calculator. Obviously, as x increases, y decreases because each time x grows by 1, y is 10% less than the previous value. Finally, I plotted the points on a separate graph from the one I did before, and here it is obvious that this is an exponentially decaying function because the line of best fit is slightly curved. To help me see how this data would look in comparison to my other data, I put a line where my new graph starts on my other graph and plotted my points there. In conclusion, the world population is growing exponentially at a rate of about 12% each decade. But if a significant event such as the supervolcano in Yellowstone National Park were to erupt, it would devastate the areas surrounding and eventually affect the rest of the world in a very drastic way because the population would decrease.